Hello, and welcome to today's webinar on predictive maintenance, brought to you by Plant Services and Spectra Scientific. I'm Tom Wilk, Chief Editor of Plant Services, and would like to express my appreciation to all of you for joining us today. This webinar is sponsored by Spectra Scientific. With more than 8,000 instruments sold and customers in 6 continents, Spectra Scientific is a leader in the field of condition-based maintenance and oil and water analysis. Now, before we start the presentations, there are a few housekeeping issues I'd like to review with you. On your screen, you should see several primary sections. The upper left, or audio control section, allows you to adjust the volume of the presentation. Just hover over this section with your cursor until you see the audio volume control, and then adjust it to your preference. To the right, in the largest section, is where today's presentation slides will be displayed. Under that slide window, you'll see a chat section where you can chat live with fellow audience members. To the left of the slide window is the questions and answers box, and this is where you can type questions for the presenters at any time during today's webinar. We'll get to as many questions as we can during the Q&A session following today's presentations, and if we're not able to get to all questions, the presenters will be able to reach out to you one-on-one by email to help answer those questions after today's live day has ended. The handout section at bottom left contains links to several resources, including a PDF of the full set of speaker slides, and 2 articles from Plant Services on how to identify hiccups in your PDM program and then get the program back on track. Finally, at the bottom of your screen, you should see icons for additional features. By hovering over each icon, information about that icon will be displayed. If you have any technical problems, you can type in your question or concern in the questions and answers box, and one of our technical engineers will assist you. If you need a better view, especially of the slide window, you can enlarge any section you like by clicking on the box in the top right corner of that section, next to the X. If you accidentally close out a section, you can get it back by clicking the Restore icon at the bottom of the screen. It's the leftmost icon in the shape of a double arrow in a circle. This webinar will be archived, and we encourage you to direct coworkers to the recorded presentation. Finally, at the end of today's presentation, we'll ask you to complete a very brief survey to give us feedback we need to improve these webinars. Now, today's speakers will be Ken Caldwell and Dan Walsh of Spectra Scientific, and they'll be presenting on rebooting an oil analysis program. Before the presentation begins, we're going to set the table a little bit by recapping some information from Plant Services articles that were published on this topic of predictive maintenance, restart, and scale-up. We published 2 cover stories on this topic, as you can see there, one called Shake Off the Rust and one called Sustain PDM Success. And I'd like to go through a couple of the lessons learned from those stories with you. For the Shake Off the Rust article, we ultimately identified 7 common hiccups that can get in the way of a predictive maintenance program, despite everyone's best intentions. For the articles, we polled a lot of practitioners in the field, and you're going to hear a lot about this topic from these practitioners. The first roadblock that we observed was the buy it and forget about it roadblock. Brendan Rush from Southern Garden Citrus continues, where after he found the PDM tools in a dust-covered box, he mentions there was this thought that by buying these devices, we'd now have PDM, and life would be great. There wasn't any really foresight into building a PDM program. So I'm not sure how many of you have experienced this. The second tip is that when you're using the tools and you get a win, there's no celebrating of the win. That was observed by Shane Jones, who's the operations and maintenance manager at the Salt River Project. One of the other things that Shane noted was that this was a lot like the old rules about touchdowns in the NFL, when they call it the no fun league. You know, there's no sense in expecting a program success if you can't really celebrate that win and communicate it throughout the plant teams, both on from everyone from the floor level up to the C-suite. A third roadblock is simply a lack of follow-through. Say you've got the tools, say you've got the ability to communicate, you start doing measurements, but there's no corrective action taken afterward. That was observed by Michael Trainer of SKF. And one of the things that he said, he noted that one One client they work with in the third month had a catastrophic failure in a critical motor, which required 8 hours of downtime and about $20,000 in incurred repair and mechanic labor costs, which could have been avoided if somebody had simply remembered to write up the work order and take corrective action. A fourth one is lack of resourcing, and this may be in your hands or out of your hands. A lot of times it is out of your hands. Bob Tizar of the Wonderful Company reported that he heard of a plant where one short-term plant manager reduced the PDM team to one person. Ultimately, what happened in that case is that the reduction in reliability hit hard after 9 to 12 months, by which time that plant manager left the company. So lack of resourcing, you can feel some immediate pain, but also there's some downstream costs as well. The fifth of seven is what to do about repeat failures. No matter how much you try and fix an asset, the failures repeat. And according to Heinz Block, this is a cultural issue. It has to do with uninformed management and a tradition-focused workforce that really can't break free of old ways of thinking and doing. He recommends that you include root cause identification and correction in any PDM program to help overcome this obstacle. The second is an inefficient use of time. You can see what Paul Dufresne of Reliability Playbook had to say about collecting, analyzing data, but spending way too much time doing both those tasks because the database hadn't been set up properly before those tasks began. Paul goes on to say in these articles that he's also seen organizations make investments in software and hardware, but then cut training out of the project. And that's a good point to remember, is that solid, reliable training can often overcome these inefficient use of time issues. Lastly, from Joe Anderson, who's currently working for B. Braun Medical, he identified cultural issues and identified these three factors as obstacles. Program managers failing to show the value of PDM, change in management, and simply insufficient knowledge and training. I think the curious thing here is that Joe has made it one of his missions to make sure that plant teams, especially maintenance teams, are armed with the vocabulary to communicate what ROI is to their managers and their managers' managers, to make sure that they can speak the language of business impact when it comes to these PDM programs. One last slide from me. Part 2 of the article focused on sustaining PDM success, and I'll simply leave the 7 critical program success factors up here in this slide. Some of them are maybe intuitive, some of them maybe not. But again, both this article and the one about shaking off the rust are available to download in the handout section if you want to read the full account from all these contributors on what issues they see with PDM programs stumbling and what sort of steps they see you can take to correct those issues. So without further ado, we're going to forward on to the presentation by Ken Caldwell and Dan Walsh of Spectra Scientific, who are going to present on specifically rebooting an oil analysis program. Ken is Senior Product Manager for Industrial Solutions at Spectra Scientific, and his career focuses the application and technical product line management of instrumentation and precision electromechanical components for industrial processing and manufacturing applications. Dan Walsh is Director of Technical Sales Support and Product Line Management at Spectra Scientific and has more than 20 years of experience with oil and wear debris analysis, industrial lubrication, and problem solving. Welcome, Ken and Dan, and thank you very much for presenting today.
Thank you, Tom. Before I start, I would like to do a brief introduction of Spectra Scientific for those of you not familiar with our company. Founded 35 years ago, Spectra Scientific is the world's largest turnkey provider of oil analysis solutions for industry for predictive maintenance. We serve customers in over 100 countries in a multitude of industries, and we are headquartered in Chelmsford, Massachusetts. Today we'll cover the following. First, we will discuss briefly the current industry challenges and the need for a new approach to oil analysis for predictive maintenance in order for companies to remain competitive. Then we'll explore some of the reasons why an oil analysis program can stall and the elements of what a successful program reboot would be. We'll outline the benefits of on-site testing using the Spectra MiniLab as a model and review a couple of successful deployments. Then we'll present the TrueView 360 Enterprise Fluid Intelligence platform that addresses how companies can benefit from the standardization of best practices of oil analysis on a global scale. First, I'd like to talk about some macroeconomic trends that are driving our industry. We're literally in the middle of what's called the fourth industrial revolution, or Industry 4.0, where technologies such as cloud computing, the Internet of Things, and cognitive computing has already fundamentally changed how manufacturing is done. To stay competitive and drive profitable growth, companies are increasingly focused on greater asset availability in the use of data-driven, data-based maintenance decisions in order to drive a higher return on assets. Well, what that means is that there's an increased focus on strategic asset management to maintain asset reliability and uptime, and the reliance on condition monitoring techniques to enable predictive maintenance so that costly downtime can be avoided. I think for the members of this webinar audience, this is not news, but it's a good context that I want to lay out there going forward. So PDM has really become a core competence in this model. On the other hand, issues with an aging workplace, where an aging workforce limits the availability of in-house expertise, and some companies have begun to seek third-party solutions to that. There's also a lot of development of application-specific techniques for the higher-risk components and the familiar transition to going mobile in terms of your interface. There's already a very broad demand for intuitive software that will simplify and automate previously cumbersome, complex processes so that you can get rapid and actionable data for real-time decisions. Oil analysis for industrial plants has been an established condition monitoring technique for over 50 years. Let's look at it now. There are three main benefits of implementing an oil analysis program. First is the benefit of an increase in the asset availability and the reliability of the asset by reducing unplanned downtime, an increase in the overall asset life, increase in the asset utilization, and reducing the risk of catastrophic failures. Now the focus is on also reduction in the total operating costs from reducing the oil usage, lower maintenance costs, that is eliminating unnecessary maintenance costs and the large burden of labor that entails, and lower your recycling costs through reducing the actual consumption of oil and other lubricating fluids, and an overall reduction in inventory. Finally, improve productivity, because oil analysis can provide assistance in achieving more timely and effective repairs, improve worker safety, and improve maintenance, resource productivity, and utilization. In the context of quality data and actionable information, oil analysis traditionally has always had the reputation of providing very comprehensive and insightful information for predictive maintenance. Some go as far as to liken it to the equivalent as a blood test for machinery, where it provides critical information on the contamination, that is the physical constituents, but also the blood chemistry or the oil chemistry itself. Analysis of in-service oil samples can help you determine if the machinery is healthy by looking at things like wear particles in the oil, looking at the physical and chemical properties of viscosity and acid, and if there's any external contamination from dirt or sand, water, or other foreign fluids. The key value in an oil analysis report is that it can provide a recommendation to the maintenance team, like filter the oil, possibly change the oil, or no, it's okay to continue and have an extension on the oil drain interval, or some other maintenance action on the machine. So oil analysis in general answers these critical questions. Is the oil dry? Is the oil clean, that is, free of dirt and dust? Is it the right oil? Is the oil fit for use? And then finally, most importantly, is the machinery healthy? Can you predict when the machinery will fail? So these are what we call the critical questions about oil analysis. More recently, the prescriptive maintenance world might ask another question, which is, well, I can predict now when my machinery fail. What can I do about it? So that subject we'll come back to in the second half of this presentation. For now, let's take a close look at these categories and the underlying parameters. For chemistry and viscosity, we have water, acid number, oxidation. For engine oils, there's other parameters. For contamination, water contamination, ISO codes and counts, presence of large contaminants like oxides, elemental silicon, and other elements. These all address the question of is the oil clean and free of dirt? Finally, then, the all-important category of machinery wear, total ferrous content, the presence of large ferrous particulate, wear particle counts, the type of wear particle it is, cutting, sliding, etc., and the elemental constituents. So I want to take a moment now, and I'm going to pass this over to Dan Walsh to pick up as to why most oil analysis programs stall out. Dan?
Thanks, Ken. Tom mentioned at the top of the hour some of the key findings from talking with customers over many years, some of the potential failure areas that they have seen on why reliability programs stall. And it's interesting because some of the comments we share very similarly when it comes to why oil analysis programs stall out or are not as effective as they were first envisioned. Over our many years of talking to customers who are considering solutions or looking for better ways, we've seen a couple of common things occur. First thing to notice is that the predominant deliverable for oil analysis is usually some sort of off-site or contract laboratory. And there's a process that's involved. And the process essentially is where you have a series of samples that are pulled by the end user, shipped off to a lab, results come back in some form of either originally a paper or a fact report, and then there is some discussion on action items, and then it's supposed to be a feedback loop in order to improve the process. However, we've seen a lot of challenges over the years on why programs have not really benefited and have expanded. First is that there is oftentimes a long cycle time with off-site labs. And by the way, this is not a knock on oil labs. They oftentimes are extremely responsive once the sample hits their delivery door. We often see that there's a lot of logistics issues just getting samples off the site. They can sit on the loading dock for a period of time, and it's not easy to actually go ahead and improve that sometimes, especially because it's considered to be a lower profile issue in the plant. We've also seen as a result of that results, when they do come back, are too late to integrate into the workflow for decision making. Many times an industrial customer or a power plant or various industry will say, yeah, I got the result, but I couldn't really do anything with it, and I'm almost embarrassed now because it took too long. And so now I have to issue another work order if I want to take that out. So the value of the data in a timely manner was missing. Frequently, the lab is not clued in on all the information. So asset information is oftentimes questionable. Labels are not well laid out. Sometimes the wrong labels are put on. There's a lot of housekeeping issues. And the result of oftentimes is when there's a questionable result on the report, the request is go sample it again. So a customer often feels like they're on a on a wheel trying to get off to decide. And of course, once you introduce lack of confidence into the process, you end up stalling out any actionable information. The information as well that can come back is not very helpful, or you can have many different people trying to identify what's happening. It's a generic answer or a generic piece of information, and it's very, very lack of detail and a lack of information that's specific to the plant environment and the specific actions that need to take place. And then borrowing from another theme that we saw earlier, there's a lack of visibility within large organizations. We have seen where some facilities are exceptional success stories. They do a great work, but they're not able to leverage that success within their own network. Oftentimes, the plant next door has no idea about the success that's occurred earlier. So as a result of that, what's the advantage that we're proposing? Well, we're saying that the new approach that has to be looked at and a way of reinvigorating the program is to take a more simple and holistic approach with more on-site testing. What does this involve? Well, as Ken earlier said, the macroeconomical trend of Industry 4.0 is to take things and be more simplified and take the complications out of traditional practices and come up with a more holistic approach that improves the overall performance of the organization. The new approach has to center around the needs of the maintenance team and provide a simple process to follow to identify critical assets, determine what to sample, identify the key information that needs to be developed. On top of that, the information needs to come back in a timely manner. The information needs to have real information that is very specific to the environment or the application that it's working with. And the huge advantage here is that the existing maintenance team has a huge amount of access with timeliness. That sample that's recently collected from the machine is the most representative of the machine. So if you can sample that within 10 or 15 minutes of it actually running and get all your information, you can get a very good picture about what's going on immediately. On top of that, you can eliminate a lot of the retest information. And the other thing we find from a holistic or synergistic advantage is that by helping the end user to essentially work with them on developing their alarms, diagnostic statements, and recommended actions, the intelligence part of the overall program is greatly enhanced. We often find that the mechanics and the millwrights that are working on the equipment actually have far more information than an outside lab may have, and they can identify the problems at a very, very micro level based on the information that's at hand, if it's there on a timely manner. So with that, let me pass it back over to Ken to talk about the next stage of what we mean by an on-site solution.
So the TrueView 360 Fluid Intelligence Platform is a new approach. Is a tool developed for and with cooperation with maintenance and reliability teams. From sample preparation and test on the MiniLab to the TrueView Enterprise Platform's asset database, oil database, alarm limit sets, it allows trending of the historical data and the performance of the assets. With a rules engine that provides automated diagnostics, recommendations, and recommended maintenance actions, it also provides an opportunity, along with its performance dashboard, of actually capturing potential savings both in oil consumption as well as maintenance cost itself. So it really consists of three aspects: the MiniLab instrument itself that measures the oil sample, the device console which operates the instruments and serves to acquire the data and display it in the terminal, and finally the TrueView 360 Enterprise software for the database, which includes the rules engine and the reporting functions. The TrueView 360 Enterprise software is a browser-based platform. It can be hosted in the Spectra cloud or installed on a company server or even locally on a PC. And it provides a completely integrated solution then for oil analysis. A little bit details of the flow. I just want to draw your attention to the two main axes. One is the sample process flow from scheduling a sample, whether that's done on a calendar basis or you create a sample list as you go on a daily basis, to the testing, diagnostics, feedback, and finally the archiving the data. We'll come back to some of this in more detail. The other flow, if you will, is the information flow up top, where you have your asset database set up with a reference oil attached to it, your schedule. You may have then your test results from the measurements, the recommended actions to take based upon those measurements when comparing them to the alarm limit thresholds you've set, and finally actions, finding, savings, and closing that loop. And what did you find when you executed that work order to go bring out a filter car and clean up the oil a bit. The other aspect that I want to touch upon here now is the way this is set up. Since you can't host it in the cloud or on your company server, you can have situations where only one site might have a MiniLab. So you see that one icon that says TrueView 360 with supporting regional sites. Well, they can access information in the database and the sample list from sites that may not have any oil instrumentation in-house, yet they share the database with a more central location that does have a MiniLab. And in that way, you really have an enterprise-level view and control of your oil analysis program. And I'll come back to that in just another slide. So what does this look like? You're using the MiniLab, the standard core offer as shown here, of course, is the MiniLab 153. It answers the very critical questions I mentioned earlier in terms of oil analysis. Spectrometer gives you your 24 elements. The LaserNet gives you a particle count, total ferrous measurement, large ferrous measurement, and the important category of wear classification. The fluid scan provides your infrared analysis for your chemistry and water. And your MiniVisc is a direct kinematic viscometer measurements of machinery oil at 40 degrees C. The only point I want to make here is that all of these measurements, sample preparation, test, cleanup to get ready for the next sample, can be done in 12 minutes with this particular MiniLab. And for every piece of instrumentation, there is an ASTM method and NIST traceable validation standards. Makes it for a very robust solution and for a reliability program itself. We further simplified the program by we've included a built-in wizard, if you will, that steps through each test, telling you how to prepare the sample, how to inject the sample, how to clean up even after the sample. These little snippets are like 5 to 15 seconds in length and are just meant to be able to be prompts until your users get up and running and don't really require them anymore. But we even include a built-in timer for those couple of procedures that are time sensitive, such as agitating the sample before making a particle count measurement or degassing the sample itself. So coming back then to the flow, let's put it all together. You do your sample to start in the upper left-hand corner. Sample and test is done on the MiniLab on the TrueView device console shown there. The user would then review the measurement results, and if they want, they would also then review the software-generated diagnostics and recommended actions, can then accept them or reject them, or type in manually what their own diagnostics and recommended actions are. You can then, once you're satisfied with that aspect, you can then release and distribute the report. You can set up, even by individual asset, who's on an email distribution list for reports as they're distributed. And then finally, the missing gap is, somebody gets that report, someone makes a decision to schedule a work order, enter a work order request to request a work order be executed. Somebody, whether it's the next day or 3 weeks out, goes and looks at that particular component, maybe draws another sample, maybe changes the filter, whatever the recommendation was based upon the report. And then after that work order is executed, they can then log back into the system and enter their maintenance findings, including what actions they actually took, what the root cause of the issue was, and any cost savings associated with that preventive maintenance action. Again, then closing that out, over time, as your individual machinery becomes more and more well known to you, you can adapt those rules engines that come out of the box even to the individual asset level. So if there's known machinery that have, excursions, they're in that 3 sigma range, you can tailor the actions and recommended diagnostics on an asset-by-asset basis. Finally, you're able then to track on the dashboard at the plant, at the corporate, or even the individual asset level, various metrics. Take a look a little bit more detail. So the TrueView device console, this is the operating console, if you will. Using the drop-down up top, you take your sample from your sample list that you generated in the TrueView cloud software. You run your test. There's an instrument control where you can either launch all instrument tests simultaneously or one by one launch them if you're only doing a few of the recommended tests. Based upon the asset structure that you've set up and identified what type of component that is, for example, rotating machinery, or maybe this is a diesel generator, it will call up in that test suite which particular instruments to engage. You can, again, manually override that and launch them individually, but this way, with the selection of one button, you launch all of the test suites. Once your test is complete, the results are displayed on this test console. You have a chance to look at them, and if they look reasonable, you hit the upload icon, and what that will do is it'll send the data back to the TrueView software, where it will then populate that tri-vector chart by comparing the actual data you just measured to the reference values in your limit database. And so in that way, you have an opportunity then to just go back, select another of the samples from the drop-down list, continue it, testing, et cetera, because right here on the console itself, you can access the entire sample list for the day, run your samples. If they look good, just upload them, and then just keep on running your samples. So we talked a little bit in terms of the rules engine. One very frequently cited objection to people implementing on-site oil analysis is that they just don't know. There's this felt sense of a lack of expertise in how do you interpret this data you get so that you can make meaningful conclusions and implement an actionable program. Well, we implemented a rules engine with the TrueView software to address this. We perform a simple diagnostic simply by comparing the oil test results and the asset information, for example, what the asset type is and what the alarm limits are. The TrueView comes with a robust alarm limit set. Over time, you can certainly edit them, either the values that are in the alarm limit set in terms of the magnitude of the measurements, but you can also edit the parameters that are alarmed on. Maybe you want to add a few parameters that we don't have in our standard set. Maybe you want to remove a few that we do put in. But over time, you adapt then the alarm limits and the alarm limit sets for your asset itself. Likewise, as it compares that, there's automatically generated diagnostics and recommended actions. You can see those called out below. Over time, you can also, at the individual asset level, change what the recommended diagnostic and action is for that particular asset, and then, of course, go through the final process of releasing and notifying the user. So it's really a two-step process to ensure really a quality report. One is the software-generated automatic diagnostic and recommendation, and then there's a manual edit and review before the report's released and then distributed. And again, you can accept or reject and delete the system-generated software and manually enter in your own, with, again, the idea being over time, you'll be able to take your recommendations and diagnostics enter them into the software, have those flagged for that particular asset, for that particular set of assets. So that really is what makes the open architecture allow for an easily customizable adaptive roles engine. One of the reports we mentioned, you get a trend report with a tri-vector display, which is a shorthand summary of whether you have high or low alarm levels for the categories of chemistry, contamination, and wear. You get trend graphs of 20 key parameters and measurement data for 35 parameters, which are all grouped according to machinery wear, oil contamination, or oil condition, and color-coded alarm limits, so at a glance you can see what's going on. Once the report's been distributed, the work order executed, there's the ability then to enter a maintenance note to finally close out the oil analysis report, where you could select whether the issue was wear or contamination, whether the specific action was done. In this case, it was like, yes, we actually followed up on your observation and we checked it out, and sure enough, we had an issue with the maintenance that wasn't being followed correctly. So it provides capturing in one place the information and the result of the oil analysis. Often, a lot of times, people run reports or they get them from commercial labs, and the PDF goes into a file somewhere, whether an electronic file or a paper file. This way, we help close the loop between your CMMS. There's no interface to it, but we bridge that gap between the oil analysis program and the results of it. Finally, I mentioned the TrueView dashboard. What it provides is information on the frequency of the various states, a normal oil sample, one in the alert, one in the alarm case by percentage. It also will track the oil consumption as well as the total repair savings as estimated by your maintenance team. And it's a level-sensitive dashboard, so it can do that at the enterprise level, which would be multiple plants, the single user site, for example, where you might have a MiniLab, particular location within a site, or at the individual asset and component level. And what that allows is then that overall visibility and an ongoing way of being able to monitor the effectiveness of your oil program. So we're going to switch now to some success stories that Dan will share on MiniLab installations. Dan?
Thanks, Ken. So what Ken just showed you was an overall of how the system, an on-site system works. So one of the things I wanted to share is an example here with a customer known as Eli Lilly. And so this is an example here of work that we did recently. This customer considered bringing all their technologies on site in the last few years. And you can see here that what they did was they had a very significant amount of equipment. What's interesting is that on-site analysis, where traditionally it was aimed at process industries which were focused on continuous process manufacturing, where you had production lines on a high level and tended not to be as focused on discrete manufacturing, that has significantly changed in the last several years, especially in this overall industry of 4.0. And here's an example of a customer who put in a MiniLab system as part of their overall rebooting of their reliability program. And they were able to see significant savings and advantages as a result of doing that. And they were able to start to actually justify it from a number of different areas. Ken mentioned earlier how important it was to see failure prevention and how you can extend maintenance actions and drain intervals. But a second significant advantage as well, especially for certain industries such as pharmaceutical, is you have more traceability, which improves or lowers your overall risk of potential problems. Another organization that did very well in the last few years is the company called Nissan Automotive. And so in those particular situations, what they did was they also put in a system and decided to go on-site over a period of time. They started their lubrication program back in around 2011, 2012 with an overall training on their mechanics, their personnel, get them into good housekeeping practices, and then they use on-site analysis as a measurement tool to measure and to manage their success and their various tasks. And one of the noticeable things that they saw was that they were able to see dramatic downtimes in things such as their hydraulic systems across the board. A third type of organization that publicized its success metrics is Palo Verde Power. They're the largest nuclear facility in the country, based in Arizona. They've had an on-site lubrication analysis capability for many years, and it's considered to be a very advanced system. And what they've seen is that they've seen consistent advantages by looking at their on-site vibration and on-site oil analysis, and they see that they can detect a combination of systems very, very early when they use both technologies or a combination of them to identify early problems. And they found that oil lubricated bearings for oil analysis results usually show up earlier than vibration, and they use the other performance technology then to track in tandem and have consistently seen significant savings, all at the same time while improving their readiness level. A fourth type of system is in the maybe not so traditional in this industry, but it's worth noting where in the fleet and heavy industry where you're talking about mining, quarrying applications, they also are great candidates for on-site analysis by bringing it in-house. And what they're looking at is obviously not just the root cause determination, but supporting extending the drain intervals. And of course, like we had said earlier with industrial applications, any time that equipment is not operating, it's costing money. So any time that they can extend the reliability, increase their mean time between failure, they can do so. And what they've seen is that when they bring oil analysis in-house, they again see a reduction in their overall lube cost per hour. They see an overall reduction in savings, and at the same time that they're seeing a drop in cost, they're seeing an increase in their mean time between failure across the board. So overall, bringing oil analysis on site, putting it in the hands of the maintenance team at the right place at the right time, maintains and improves the availability of equipment across all equipment classes. And so we've seen a significant advantage to doing that. And the new technologies that Ken just described, combined with the software, the overall integrated solution now provides a platform to reboot this program. So with that, let me put it back over to Ken to talk a little bit about the Global Fluid Intelligence Platform. Ken?
Thank you, Dan. You know, one of the inevitable results of Industry 4.0 is the availability of a vast quantity of data that was really impossible to obtain before. Unfortunately, you can't confuse quantity with quality here. It's very easy for companies to be overwhelmed with this data. A recent McKinsey report looking at the Internet of Things determined that, for example, on a drilling rig, 99% of data never left the rig, that is, never made its way back to corporate to be analyzed and used on the other dozens and dozens of rigs out there. So the quality of data and information is never more important today, as companies are literally drowning in a sea of data. It's pretty easy to optimize a local oil analysis process within a specific plant. It's very hard to standardize oil analysis practices on a global scale for a corporation. There are three primary challenges. First, if using off-site oil labs to provide services, One must choose labs locally, however, to optimize the cycle time. However, it's very common that among different labs and plants, there's large variations in process time. There's even large variations in types of instrumentation in a lab. This makes it very difficult to standardize workflow on a global basis. The TrueView platform with the MiniLab solution for hardware addresses this challenge. Secondly, it can be very difficult to leverage your learnings and best practices globally. Each plant has their own information based upon their own experience, their own sorts of equipment. The closed-loop feedback of the TrueView software allows a consolidated database where there's a consolidated set of rules engines that have been developed over the broad fleet of equipment at all the company sites and then implemented locally. So local plants can benefit from this sort of closed-loop feedback. Finally, there's a general lack of visibility of oil analysis on both the local and global. It can be very difficult to see how effective oil analysis program is, and we try to address this then with, again, the maintenance dashboards and the feedback loop of providing the outcome of maintenance actions and tying it directly to the oil analysis results of a specific asset. I hope at this point you can see that your TrueView 360 Fluid Intelligence platform can help companies standardize their oil analysis best practices and really utilize it to improve their predictive maintenance practices. With the installation on either a central server or in the Spectra public cloud, companies can roll out the platform and deploy very quickly, regardless of the geography. One thing I'd like to point out as well is that within the TrueView 360 framework, any local install of the MiniLab system can easily be turned into a regional lab, if you will, because the local site that has no MiniLab can simply log in with their database into the TrueView, print out labels, mail in samples to the site with the MiniLab, and have that central site run their plants. So this helps companies to roll out on-site oil analysis in phases to help maximize the return on investment. Our experience has been with MiniLab users is that once they have an on-site MiniLab and an on-site oil analysis program in place, they very quickly found out that they can test more assets at a higher frequency and gain and expand the benefits of oil analysis to some of the balance of plant equipment. Because with time constraints and costs, only a fraction of samples of assets are tested routinely for oil analysis due to the cost of off-site testing. We've seen cases at some sites that they've increased the number of oil samples by a factor of 10 within a single year of starting up the MiniLab. And then they also have a tool where they can expand into other areas such as incoming inspection using the MiniLab to test the quality assurance of their delivered oil for chemistry and viscosity contamination. The goal of the TrueView oil analysis system is to provide lab quality data on site without the hassle and complexity of running a traditional lab. Some of the quick highlights are you install the MiniLab on a tabletop. There's no need for a dedicated lab environment. You don't need special facilities. It's like single phase, 115 volts in North America, or single phase, 220 volts elsewhere. So no three-phase power, no cooling water is required, very minimal utilities. You basically need power. Depending upon the equipment selected, from 5 to 15 minutes to run a sample to the multiple test. It's a very efficient way of allocating your resources because you can train people readily. There's a wizard to help them walk them through the sample analysis and sample preparation process. And really, with just a 4 to 5 day startup period, you can be up and running, processing your own samples with the MiniLab system. And finally, there's very little waste, very little consumables, and not much in the way of solvents used, and there's no hazardous chemicals involved. All in all, by leveraging the TrueView 360 Fluid Intelligent platform, companies have achieved program access on a global scale with easy use, simple processing, lab quality data, and the closed loop feedback for continuous improvement. One can have a ever more and more competitive environment. The enterprise dashboard helps bring visibility of oil analysis globally and allows one to then implement best practices. Thank you, and we're opening up for Q&A, and thank you, Dan, as well, for your support.
All right, and thank you, Ken, also for your presentation, and Dan as well. At this point, we're going to move into the question and answer section of the webcast. We've already seen some questions rolling in, and we'll get to as many as we can for the rest of the hour here. So we'll start right away. Ken and Dan, the first question is about calibrations. I assume with the system you described. How often do I need to check calibrations?
So I can answer that one. So usually, the system is quite easy to use, and all the calibration fluids to check to see if everything is working properly are provided. Most customers, if they haven't been using the system for a while, will run a check standard just before they go ahead and run their actual samples. If they're running it frequently, other organizations just do it on a monthly basis.
Okay, great. And note to the attendees, there's a series of optional poll questions I'll be presenting while we're doing the Q&A. So the first one's coming up now. Feel free to go ahead and register your answer. And there it is right now. The next question, guys, is about management of the site analysis program. Basically, how is the on-site analysis program managed, and do you use your staff or local site staff to do that?
So actually, the design of the programs today is to use your own staff. The goal of the program and the goal of the technology nowadays, the software and the hardware, is such that it's quite simple that it can be easily worked into the normal course of action, so that mechanics, millwrights can do that work. The information that's provided is done in a rapid fashion, which allows the maintenance team to focus their team on more effective tasks, which will be of greater value to the organization.
Okay, cool. The follow-up on that one is, would you guys say are you guys saying or assuring that you can do an on-site oil analysis program?
We're saying now that the technology is such, with the ease of use of the technology and the quality of the data, which is equivalent or better than what you'd get in an off-site lab, combined with the knowledge management of being able to manage all that data in an easy fashion and get automatic recommendations and nice reports quickly and easily, you are able to do that yourself and be able to provide the level of service for your equipment that you could not do before.
Okay, great. Quick note, we'll put the results of the first poll question up, and then we'll forward to the next poll question. The next Q&A question is, do I need a lab space and facilities for on-site testing?
I could answer that.
Yeah, Ken, why don't you take that?
No, there's no lab facilities requirement in that you do not require any of the traditional accoutrements. Literally what you need is single-phase power. That's all.
Okay.
That's it.
And that's it? You're ready to go. Okay. 2 follow-up questions on that one. Can the system can the TrueView system upload data to an M&D center? And related, what's the thumbnail of the cost of equipment like this?
So I suppose I'll take the first question. Maybe Ken, you take the latter one. So yes, so the system is a way of gathering all the data in one location. And so once you have the data in one location, there's always ability nowadays to create some sort of a transfer file, like a CSV or a TXT file. But usually the center that you're going to send the data to usually is the person that, or usually is the group that dictates how that data is going to go in. So it's a conversation that needs to be had with wherever is receiving the data to be able to map it properly so that it works seamlessly. But the TrueView and the various systems out there allow you to have an option.
Okay. Let's see. I will advance the poll slide question here. We see the results of that poll question. Next poll question coming up right now.
I just wanted to comment on that, if I could, on that first poll question. It was interesting.
Absolutely.
Yeah, it was interesting to me that roughly 30% of you had another plant, if I understood the question correctly. Could you pull that other question back up?
Yeah.
Yeah. So this would be an example where the enterprise version of it, where one plant could have the MiniLab, whereas some plant that did not have the ability to do all the tests could still have the benefit of the rules engine and the TrueView reporting and all those functionalities just by syncing with their database and sending their samples into that sister lab.
Okay. Okay. Let's see. We'll move back to this poll question right here. Give people a chance to do that. I think we have time for maybe one more out loud question. And the question looks like it is there anything specific to measure and control varnish in mineral oils?
So I can take that question. So varnish is a challenge, particularly in a certain segment of power generation industry. It was a big challenge for quite some time. There is a series of approaches nowadays to tackle varnish. First, lubricant manufacturers have started to offer on the market lubricants that are varnish resistant. So that's step one, is to look for prevention. Number two is the duty cycle for power generation has changed so that the varnish issues are becoming less of a concern. Three, from a testing perspective, it's usually a combination of leading indicator, some of which are covered by the technologies that are identified in these mini labs. And then the latter part is that if you have something known as something like a remaining useful life test or ruler test, that can be, that information can be manually entered into the TrueView system so that you can trend that data along with the other tests that you're doing and keep that all together.
Excellent. Okay, well then let me squeeze in one more out loud question, one more poll question. We'll show the results of that poll question real quick. And then one more poll question. The last out loud question, hopefully it's a quick yes or no-ish answer. The question is the MiniLab recommended for a mobile testing ban?
So I think what it was for mobile application, so there are two approaches with that. The design of the MiniLab was such that you don't have a all-in-one system. You have a variety of different equipment, so you can take components that are mobile or portable. If you're going to be, however, focused with mobile equipment, there are other technologies that are similar that do the function as well as MiniLab that are more focused on fleet systems. We would recommend maybe look at a Microlab system for that. And it also has its own rules and recommendations for reciprocating equipment.
Okay, excellent. Well, then I'll move to close out, guys, since we're very close to the top of the hour, and I'll leave the poll question active for the next, say, 60 seconds while we close out here. Thanks very much to our sponsor, Spectra Scientific, for sponsoring today's webinar. Thanks very much, Ken and Dan, for presenting, and thanks to all the attendees who joined us today. This webinar has been recorded and will be available shortly for on-demand viewing. You're also encouraged to visit plantservices.com to gain access to even more tools and resources aimed at helping you achieve PDM success, and also share this webinar with coworkers who might benefit from the information inside. The full set of speaker slides from all of our presenters today, both myself and Ken and Dan, will remain available for on-demand viewers in the handouts area, as well as the 2 articles from Plant Services on how to overcome hurdles to success with your PDM program. Lastly, did you like this presentation? Let us know your thoughts by answering a brief survey that will appear on your screen shortly upon closeout. Your candid answers are not only appreciated, they help us craft future events. So with one last slide forward, we'll show the results of the last poll question, and I'll say out loud, Ken and Dan, thanks very much for being with us today.